Okay, this is section 11.9 and 5.1.5.2. This is part 2 of your video. Okay, in part 1 we talked about the standard normal distribution curve and its characteristics and then how to calculate a z-score. On this one we're going to actually start finding some areas under curves. Okay, so we're going to use table A to calculate areas under a standard normal curve, but in order to do that we got to do some things here first, get you kind of understand what this is about. So again, it says here, draw a normal curve unless one is provided. Most of the time, you're going to have one provided for you, okay? The second thing is you want to draw a line showing the mean. Remember, in a standard normal curve, the mean's 0, and the mean always goes in the middle. Don't forget that, okay? You're going to have to calculate some z-scores, just like we did in the last section in part 1. Once you calculate that z-score, you're going to draw a line where the z-score will occur, okay? It's either going to be to the right of 0 or to the left of 0. Again, you're going to have to gauge where it's at. Again, you have to know where the number is on a number line. Okay? The table A chart, which you'll see is down here below in the pictures. Okay? The table A chart gives you the area to the left of your z-score. So, in this case, your area to the left of the z-score, okay, if the area is to the left, if it's less than, then you're simply just going to find the number on the chart, and I'll go through and explain how to do that. Okay. If it's to the right of or greater than, you're going to have to take 1 minus the value from table A. Remember, the area underneath your whole curve is 1. Okay. If I want to know the area to the right of the z-score, I've got to take 1 minus that value to get, because remember, anytime the chart is always going to give you the area to the left of the z-score. Okay, so if the area is between the two values, you're going to take the larger value minus the smaller value. Okay, the larger value from your z-score minus the smaller value from your z-score. Okay, so here's table A, and I'm going to zoom in on this a little bit, and you'll get a copy of this when you come to class tomorrow. Okay, and now you're going to have to follow along with me here. So I'm going to write in, let's say we calculate a z-score of, let's say, 2.35. Okay, that's our z-score. Now, you'll notice here on the charts you have a positive chart and you have a negative picture. You're going to get this front and back. If it's a positive number, you use the positive chart. Negative number, you use the negative chart. Okay, so we've got a z-score value of 2.35. So I'm going to take the first two digits, the 2.3. That tells me I'm going to go down the left column. I'm going to come to the 2.3. Okay. The last digit is the hundredths digit, which is 0.05, which tells me I'm going to come to this column. And I figure out where those two columns meet, and z-score of 2.35 has an area under the curve of 0.9906. Okay? So that gives you an idea of how to use your z-score table chart. Now, I'm going to go through this, and as I'm calculating these, I'm just going to go through and give you the z-score value. Again, we'll work in class tomorrow on how to find those again some more. Okay? Okay, so now let's take a look at the first example here. It says, a survey indicates that people use their cellular phones on an average of 1.5 years before buying a new one. That shouldn't be bullying, that should be buying. That's a major mistake. Okay? Before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability or the area under the curve that the user will use their current phone for less than 1 year before buying a new one. Assume that the variable x is normally distributed. Okay, so the first thing you want to do is you want to draw your mean first. So when I draw my mean, draw a line down the middle. Remember, your mean is always in the middle, and your mean in a standard normal distribution is the number 0. Okay? Second thing we got to do is we got to calculate a z-score. So our z-score here, calculate the z-score as we look at this here. It said here on average, so the average or the mean is 1.5. The standard deviation is 0.25. The value I want for it is less than a year. So I'm going to take 1 minus the average divided by the standard deviation. And the z-score that I want is going to be exactly -2. Now, as you look at your distribution, your bell curve, treat it just like a number line. Where would -2 go? Well, -2 is going to go over here to the left of 0. That's -2. And it says, I want to know the area or the probability. They'll use probability. That means area under the curve for it less than -2. Well, less than -2 is this way. -2 in that way. -2 into the left. So, what I would do right now is I would look at my table A, my chart. I would go down to 2.0 to -2.0 and use the 0.00 as the hundredths, and the value that I come up with, okay, for the area underneath the curve on the chart is 0.0228. Now, if you think of that as a percentage, that would be 2.28%. Remember, how much is the whole area underneath the curve? The whole area is 100%. And if you think about this, this area right here is not very big. So 2.28%. Okay? The probability that they will use their current phone for less than a year, it's a 2.28% chance. Okay? Okay, let's take a look now at the second example. So the survey indicates that for each trip to a supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store is normally distributed and is represented by the variable x. A shopper enters the store. Find the probability that the shopper will be in the store between 24 and 54 minutes. So now instead of one value, I've got 2. So, put that average in here, that mean of 0. Okay, mean of 0. And now I've got to calculate z-scores. And unfortunately, I've got to calculate 2 z-scores on this one because I have 2 values. 24 is the first value, minus the average, which is 45, divided by the standard deviation, which is 12. And that z-score is -1.75. Okay. The z-score for 54 minus the average of 45 divided by the standard deviation of 12, and this is 0.75. Okay, now, as I look at this, -1.75 would be over here. 0.75 would be over here. And I want to know the area in between the two. Okay, I want to know the area in between the two. Now, if you'll remember from the first part, to find the area in between, we're going to take the large value minus the small value. Okay, because remember, anytime they give you anything from the chart is always the area to the left of the curve. So, for 0.75, we get a z-score value of 0.7734. For -1.75, we get a z-score value on the chart of 0.0401. Okay. Now, in order to find the area between them, I take the largest, which is 0.7734, minus the smallest, which is 0.0401. And that will give me an area underneath the curve of 0.7333. Okay, so 73% chance you're going to be in there between 24 and 54 minutes. Okay, now let's take a look here at this last example. We're going to use the same problem, okay? Find the probability that the shopper will be in the store for more than 39 minutes. So again, I still need to calculate a z-score. My z-score is going to be 39 minus the average, which remember, the average was 45, divided by the standard deviation of 12. And if I calculate that, you come up with negative 0.5. That's the z-score you're looking at on the chart. So, as you draw this first number in here, remember that's 0, negative 0.5 is going to go about right in here. And I want to know for when they're going to be in the store for more than 39 minutes. Remember, more than 39 minutes will be the area to the right of the curve. So in order to figure the area out to the right of the curve, I've got to take 1 minus my value. So my z-score for negative 0.5 is 0.38, or sorry, 0.3085. Well, that's the area this way. 0.3085 is the area this way. In order to find the area the other way, I've got to take 1 minus that value, and when I get that, I will get 0.6915. Now, if you look at your area, this is your area underneath the curve. Does it look closer to 30% of the curve or 69% of the curve? Well, it's way more than half, because remember, 0 is at half. So that's 69% of your curve. Okay? All right, so this is section 11.9 and 5.152. Okay, we found the areas underneath our standard normal curve in this section. We also calculated z-scores, and we talked a little bit about the properties of a standard normal distribution. Don't forget to complete your WSQ once you get done watching these 2 videos.